Yes, welcome everyone. We are basically going to look at descriptive statistics, and I think we have a few slides. So within the next 20 minutes, we should definitely be done in this session. Um, so basically, in biostatistics, we look at two major branches of statistics. The first being the inferential statistics, and then the other being descriptive statistics. So we are going to look at descriptive statistics and what they really mean. Okay, so that is going to be our area of discussion. So when we talk about descriptive statistics, we basically look at how we can summarize or even describe a data set that has been given to us. So, for example, you can have a class of, let us say, a class of 10 students. Okay, you have a class of 10 students, and then you give them a test, and they have different scores. You can get 60, 70, 80, 90. Okay, but when you have a list of these students with their marks, you may not really get to understand how they really performed because you're not looking, you don't have concrete figures to really describe or even summarize that data that you have, which you're basically calling a data set. So using descriptive statistics, you can get insights. Okay, you can get insights about the data set that you have. So that the descriptive statistics help us to summarize and even describe data sets such that we can easily understand it and make good conclusions about the data set. So we have um, two major uh, measures of describing statistics broadly. So we have the measures of central tendency, and then we have what we call the measures of uh, variability. Those are the two broad measures that we have. So each one of these actually, they have their own different measures. So let us start with the measures of central tendency. With measures of central tendency, we want to see um, the different um, data points. How, how are they closer to the center? Oh, we are basically looking at the average of the data set, and we look at three major measures: the median, the mode, and then the mean. So let us start by looking at the mean. The mean is what we often call the arithmetic. Just one minute there. When you join, make sure you mute. Huh? All right. So the first measure of central tendency is what we call the mean. The mean is basically what we often call the arithmetic median or the average. Okay. The average can be looked at as the sum of all the values divided by the number of values. So if you have 10 students who sat for a test, you get their marks, you add them divided by the number of students. So you get the average score or the mean score. You can use that as a way of summarizing data if the data set is symmetrical in distribution. What we mean symmetrical in distribution is that the data should not be skewed, meaning that you should not, the data should tend towards what you call normal distribution, which is usually a bell-shaped curve. If you can check that out, normal distribution is the bell-shaped curve. Issues to do with intelligence, height, those ones usually follow the normal distribution. So it is usually a symmetrical distribution. If you have data set that is like that, then you can use the mean. Why? Because if you have what you call outliers, then you're going to have skewed results in terms of your mean. For example, if you have the 10 students, majority of them have B's and A's. So they have 80s, they have 70s, they have 75, 85, 90. And then there is this one student who has got 15%. Now, when you add the marks and then divide by the number of students, the average is going to be low, or the mean is going to be low, because of this student who got 15. So it is going to lower the average, and that 15% is what we call the outlier. So the outlier can distort the mean considerably, and that is what we call skewing. It will skew the results. So that's the disadvantage of the mean, is that it is very sensitive to extreme values. Similarly, if you get most of the students scoring below 30, and then you get another one who gets, let us say, 95, and then when you add, you will see that the average will a little bit increase, but that is not really giving us very good information about the data set. The other also example is when you say that the average salary for my staff is, let us say, $600. Okay? When you have that average, it sounds like, okay, now that is not bad. $600 every month, that is not bad. But then, when you look at how much each individual is getting, you realize that actually the MD, the managing director, is getting 20,000, and then the rest of the staff are getting below $400. But when you have that big value plus these small ones, you get the average of about $600 or $700. Okay, so that is the disadvantage, is that the mean may actually not portray the reality. So the next measure is what we call the median, which is the middle value after you arranging the data set in either ascending or descending order. Okay, it is also very useful if you have outliers. At least for it has that advantage that it is not very sensitive when you have outliers. But the challenge is it does not really consider the actual values on either side. It just looks at which figure is in the middle. So that is the disadvantage it has. And then the last one of the measures of central tendency is the mode, which is basically the number, the figure or the value that appears most times in the data set. So which one has the highest frequency? It is very good to use when you have what you call categorical data or discrete data. The challenge is that sometimes you can have data set, and that data set does not have the most appearing number of value. So that is the potential weakness you can have there. So let's look at one example of how you can really do the calculations for mean, median, and mode. So the mean you add and then divide by the number of times or the number of elements in there. So we have measurements of blood pressure, systolic blood pressure readings in millimeters of mercury. Okay, So with that data set, you can calculate the mean, which is the sum of the different systolic blood pressures divided by the number of times that this systolic blood pressure has been taken. So in this case, it is actually 10. So you divide the sum over the number of values, which is 10, and then you get 120 and 125 millimeters of mercury as your mean systolic blood pressure. And then we have to the median, which you can actually arrange the systolic blood pressures from the lowest to the highest. The one which is in the middle forms the systolic, forms the median. And in this case, it is 120, which is actually in the middle. And then the mode, which is basically the number which appears most times. And I think in this data set, we do not have the number which is appearing most times. Do we have one here? I think there is one here. 120, 125. 125 is the number which is appearing at least 2 times. But there is also 120 which is appearing thrice. Okay, so really there is no value actually. There is no value that appears more than that. Okay, so someone is joining us. Okay, so we move to the next category of measures. Now these ones are called the measures of variability. These ones, how spread is the data set? Okay, how spread is the data set from the center? We usually have 3 things to measure with this: the range, the variance, and then the standard deviation. So the range is basically the difference between the highest and the lowest value. So you just subtract. Okay, subtract the minimum value from the maximum value. Okay, it is very quick. You can always tabulate that. It's very quick, but also it is sensitive to outliers, like we explained with the mean, and does not actually have considerations for the distribution within the range. So it just gives us the value, nothing much there. So that is the range. The next one is the variance. Okay. So the variance is the average of the squared deviations from the mean. Okay, this is to mean that you can have you have the 10 students with the different scores, and then you calculate the average scores. Okay, the average score for that particular exam. So for each score, if a student got 50%, so you have 50% minus the average squared. Okay, and then you move to the next one like that, and then you divide by the number of students in that class or who sat for that paper. Okay, so it is a very good measure of dispersion. Um, the units are not easily interpretable as they are usually squared, but they also actually help us in getting the standard deviation. So the standard deviation is basically the square root of the variance. Okay, so it means that you need to first calculate the variance, which we have looked at, get the variance, and then square it, have the square root of the variance, and then you get the standard deviation. Okay, standard deviation basically means that what is the average distance of each data point from the mean. Okay, that is standard deviation. I think most of these we shall look at them tomorrow when we are looking at what we call inferential statistics. Yeah. So let's look at the example that we have for measures of dispersion. Okay, still we are using hypothetical data on systolic blood pressure. So we have taken those measurements. We have 125, 128, 130, 130, 132, 135, 136, 140, 142, and then 145. Okay, so we want to see how this data is actually spread. It is what we mean by measures of dispersion. How are they spread? So the first measure is the range, the maximum minus the minimum. So the maximum here is what? What is the maximum figure there?
Is 148.
148? Do we have 148?
145, I mean. Is 145.
145, yes. And then the minimum?
Yes. The minimum is 125.
Yes, 125. So the range becomes 20 millimeters of mercury.
20. Yeah.
Variance. So now let's move to variance. Remember, variance is the average of the sum. Let us just say this. The steps of calculating variance are basically three. Okay? You first calculate the mean. Calculate the mean, which is basically the sum divided by the number of the values, which we have looked at. That is step one. Step number two, for each value, okay, which we usually call for each data point, subtract it. From it, you subtract the mean and then square it. Okay, and then square it. Okay, so for each figure, so starting, for example, for 120, let us start assuming we have calculated the mean, which is 131.3 millimeters of mercury. So we are going to, for each point here, we are subtracting the mean and then square it. For each point, subtract the mean and square it. For each point, subtract the mean and square it. Each point, subtract the mean and square it. After that, now you add all of them. Okay, add all of them. After adding all of them, that is the sum of the squared difference divided by the number of values, which basically here the number of values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
The 10.
Yes. So
Yeah.
you get the sum of the squared differences divided by the number of values. Okay? When you get that figure, that is what we call variance. Okay? Now, after getting that figure, for you to calculate standard deviation, you have to get the square root of the figure that you have got. Okay? So the interpretation, the importance of this standard deviation, and even the variance will make more sense tomorrow if we look at inferential statistics. But for now, we have looked at the fact that when we have one category of statistics that we call descriptive statistics, which helps us to summarize and even describe data. So it gives us an idea of what kind of data set we have. So we can use measures of central tendency, which include the median, the mode, and then the mean. But we can also use the measures of dispersion, which include the range, variance, and then standard deviation. And we have looked at how to calculate each of those. So if